Hello everyone. Today we're looking at the problem Reschedule Meetings for Maximum Free Time 1, which was question 2 in Biweekly Contest 149. The question reads that we're given an integer value event time, denoting the duration of an event, where the event occurs from t equals 0 to event time. So the event starts at 0, goes to event time. We're also given two integer arrays, start time and end time, and they are each of length n. And these represent the start and end time of n non-overlapping meetings, where the ith meeting occurs during the time, start time to end time. So what this is saying is we're going to get two arrays representing the start time and end time of n events. So for example, if we have 0, start time 0, end time 0 represents that event. We can reschedule at most k meetings by moving their start time while maintaining the same duration. And we want to maximize the longest continuous period of free time during the event. So the relative order of the meeting should stay the same, right? So we can't swap their positions, but we can shift events around. So we want to return the maximum amount of free time possible after rearranging the meetings, and we cannot arrange them so that they are outside the time of the event. So looking at this input, we have event time equals 5, k equals 1, and we have our start times of 1 and 3 and end times of 2 and 5. And you'll see how that translates here to the event. So we have start time 1 to 2, so this is our first event, and then start time 3 to 5, which is our second event. And the answer here would be 2. And the reason is we can take this event 1, 2 and just slide it over into this 2, 3 position. So then at that point, this entire area from 0 to 2 will be open. So then we can consider that to be our longest continuous free segment, and we can return that. So before diving into an example, I want to go over something conceptually that will be very helpful for this problem. So this just represents a line with a bunch of events on it. So these dashed lines are the events, and then these red arrows represent spaces. So let's say here that our k equals 2, right? We can move 2 events. So let's say that we're looking at this space right now, and we want to maximize how much space we have around this space. So we're going to keep this consistent, but try to add space to it. So how do we do that? Well, if we can move 2 events, one option is to move these 2 closest to my left, right? And what I would do is I would slide these all the way down as far as I can. And why would we do that? Well, we would have this space here remaining, right? But essentially what we would do by doing that is we would shift this space over to here, as well as this space over to here. And why does that happen? Well, because you can imagine, say we slide this first event all the way to meet this one, right? That would basically add this space onto here. And now if we did both of them, right, if we slid this one, then slid this one, that would add this space here as well as this space here. So that's one option, right? If we can move 2, we could move these 2 over here and basically transfer this space over to this space here. Another way we could do it is we could move this event here to the left and move this one to the right. So what we're doing here, essentially we are adding these 2 spaces onto this middle one. So this one would join here and this one would join here. And really the last way we could do it is we could just do the inverse of what we did first. We could take these 2 events to the right and we could shift them this way. So what that means is that we would add this space and then we would add this space, right? So if we kind of keep our space pivoted in our mind, right, we keep this fixed, then we have a couple different ways that we can go over these spaces and add them together by moving events around. So if we really examine what we just did here, let's think about it. So first we did this. We gained all these spaces here. And you'll see this is a window of 3 spaces. Then we did this. We did this space to this space. Again, a window of 3 spaces. And then finally here, we did this, right? Another window of 3 spaces. So you might be noticing a pattern here. what we could do to solve this problem is we could just take k plus 1 and have that as our window. So you'll see here our k is 2, but we're going to look over 3 spaces, and we're just going to shift this window through our entire array and find the maximum spaces that we can put together. And we know that we can do this, right? Because we know that if we're looking at a space, we can shift to the left, we can shift the ones on the side, or the ones to the right. So really what we're going to do is just use the knowledge that this is the way to maximize the space around, to just use a window and slide it across. And you'll see exactly how this works in the example. So looking at the example where event time is 10, k is 1, and we have 3 events. So we're going to have our line going up to 10 just to represent the total event time. Here we have k equals 1. So this is an interesting case because we can only shift one event. And then this just represents our events. You'll see here 1 from 0 to 1, 1 from 2 to 4, and 1 from 9 to 10. So we had elaborated previously that we want to make a window of size k plus 1, and we want to iterate over the spaces. But you'll see here what we actually have is the events. We don't have knowledge of where the spaces are right now. So what we can do is we can actually build that array. So the first thing we're going to do is our first space is going to be from 0 to wherever our first event starts. So here we'll see it starts at 0, so we can just add a 0 into our array. Then our next space will be from wherever the first event ends and the second begins. So we now have another space of size 1 right here. Then again, we have another space of size 4 to 9. So this will be 5. Then for this last one, there are no additional spaces because this goes right up till the end of our event. So we don't have to add anything here. So you'll see now what we have here actually is we have all the spaces and their size in this array. So now we can just apply our window. So we can go of size 2 here and size 2 here and just compare. And this is a pretty simple example. It's a very short array, but you could imagine if we had to do this for a much longer array, right, say we went all the way here, and what if our k was, say, 100, this could get inefficient pretty fast. So what we can also do is do a prefix sum. We're going to take these and we can just add them up. So we have 1, 6, and then we can do this to do it in constant time rather than iterating through k each time. So overall, this is going to be an O of n solution, right? So we're iterating over the events one time. We're going to do O of n for our prefix, and then we're just going to do this prefix calculation in constant time and find what our largest continuous segment would be. Let's hop over to the code and see exactly how this works. So the first thing we're going to do here is start setting up our spaces array. So like I said, the first space is going to be a space starting from 0 and going up until our first event. So really what we're going to say is this space is the size of however long it takes to start my first event. So we can just put start time 0 in here. So say, for example, our first event starts at 2. We know there's a space of 2 starting from 0 and going to 2 for that first event. Then for all the events from 1 till the end of our events, we can add in the start time of the current event minus the end time of the previous one. And when we get to the end, if our end time of the last event does not equal the event time of the entire event, we can just add that difference in as well. Then here we do our prefix sum array. So we're just going to start with 0 in there. Then for each element in their spaces, we're going to add that value plus whatever we saw before. Then we're just going to go through our array and keep track of the maximum value we saw. So we're going to start our I at k and go up to the length of our prefix. And we're doing length of k because we're going to see what we get by going from k on the right to minus k on the left. So say, for example, our k is 3. What we're going to do is say, I'm going to start my right boundary at 3 and see what I can get by doing everything up from the beginning until this k, right? So we don't want to start before that value because we're going out of bounds to the left. So what we do at each step is we're going to compare whatever we already found, and then we're going to take whatever is at our I value and we're going to subtract either I minus k minus 1 from that, or 0. So it's potential that this could go out of bounds for us. So here we would just want to do a maximum of 0 if that is the case. Then at the end, we're going to return the maximum of what we found, or the largest space in our free spaces. And why would this happen? So you could say, for example, maybe we have only one free space, but then we have a lot of events that are right on top of each other, right? So say we have 3 events on one side that are directly connected and 3 events on the other side directly connected. In this case, we can't move these if our k is 1, for example, right? Because we'd have to remove all of them. So this handles the case where maybe we can't really move anything, so we're just going to take whatever the largest actual space is that we have in the array. So let's submit and make sure that it works. And it does work. Hopefully this is helpful and it made sense. If you liked the video, please like and subscribe, and thank you for watching.